Welcome to 15-Minute Discourse, where we take a deep dive into some fascinating topics.
Yeah.
And today, we're heading to the red planet Mars
Oh,
to explore all the possibilities and challenges of colonizing it.
very cool.
We got a ton of sources for this one, reports, scientific papers, even some historical perspectives
All right.
to really get into the nitty-gritty of whether humans could actually live on Mars.
Right. Yeah, it's a question that's fascinated people for centuries.
Totally.
And these sources, really explore it from every angle.
For sure.
We're talking the stark realities of the Martian environment,
Yeah.
the technology that we'd need to, make it happen,
Yeah.
even ethical dilemmas of, transforming a planet for us.
Yeah. Okay, so let's get started with the basics.
Yeah.
What's it actually like on Mars? Paint me a picture.
Okay, so imagine a world with an atmosphere so thin, it's basically non-existent.
Right.
I mean, this means no protection from the sun's radiation. On Earth, the atmosphere shields us from that harmful UV radiation.
Right.
But on Mars, you're just exposed.
That's scary.
And that thin atmosphere also means crazy temperature swings.
How crazy?
We're talking a 70-degree C difference between day and night.
Oh, that is a lot more than a little chilly.
Yeah.
I mean, is it like Antarctica, but just with even more extreme temperatures?
Yeah, for the lower latitudes,
Okay.
it's a good comparison.
Okay.
The NASA rover data shows it's pretty accurate.
Okay.
And you remember that atmospheric pressure we talked about?
Yeah.
Well, it's similar to what you'd find at the highest altitude reached by a balloon,
Oh, wow.
38 kilometers up.
Okay.
So you would need pressurized habitats just to survive.
Wow, it sounds like existing on Mars would be a full-time job.
Uh-huh. It definitely wouldn't be easy.
Yeah.
That's why creating those artificial habitats is so important if
Yeah.
we ever want to, do a Mars mission.
Yeah.
These totally self-contained environments with life support systems. And one of the biggest hurdles,
Yeah.
water.
Oh, right. Of course, because humans need that.
Exactly. We can't live very long without it.
Right.
The average person in the UK uses between 70 and 140 liters of water every day.
Seriously.
Yeah. So imagine shipping that to Mars.
Oh, my goodness.
Not really cost effective.
I'm going to start appreciating my long showers a lot more.
Uh-huh.
What's the solution then?
Well, the astronauts on the International Space Station,
Yeah.
they've gotten incredibly efficient.
Oh, really?
They recycle 70% of their water.
That's amazing.
But even that wouldn't be enough on Mars.
Right.
We need to find a way to use potential water sources on the planet itself.
Okay.
Whether it's frozen ice or something.
Yeah.
Maybe drilling could work, but it's going to be tough.
Okay, so we've got extreme temperatures.
Yeah.
Thin atmosphere.
Yep.
Water scarcity.
Mm.
What else should we be worried about?
Well, NASA sums up the big challenges of space travel with this acronym.
Oh, okay.
RIDGE.
Rid.
Yeah. It stands for radiation, isolation, distance, gravity, and hostile environments.
Okay, so a lot to unpack there.
Yeah, and each one has its own set of problems.
Right.
But let's focus on gravity for a second.
Okay.
We've all seen those videos of astronauts bouncing on the moon.
Yeah,
But what does low gravity do to your body long term?
that's a really good question because we're just not designed to live like that.
Yeah, and on Mars, the gravity is only 38% of Earth's.
Oh, wow.
So the effects of microgravity would be a big worry.
Yeah.
Here's the thing. In microgravity, your blood flow changes
Oh,
because there's no force pulling it down,
right.
like on Earth.
Yeah.
This can lead to weak legs, sometimes called chicken leg syndrome,
Oh, gosh.
because of muscle and bone loss.
I'm getting nervous just thinking about that.
And it's not just the muscles.
No.
Astronauts actually lose blood plasma when they come back to Earth, around 17% in some studies.
Goodness.
This can cause a lot of health complications. Imagine coming back from Mars after years.
Yeah, that would be very rough.
So yeah.
Okay, so let's say we figured out how to survive
Okay.
this crazy Martian environment. How do we even get there?
Well, the good news is that energy-wise, reaching Mars is pretty straightforward.
Okay.
It takes less energy per unit mass than any other planet,
Real.
except Venus.
Okay.
And the most common way to get there involves something called a Hohmann transfer orbit.
What's that?
Basically, it's the most fuel-efficient way to get from Earth to Mars,
Oh, okay.
using the planet's gravity to help us out.
Oh, that's cool.
Yeah.
So how long are we talking? Weeks? Months?
Or 9 months.
9 months.
Yeah, like a space pregnancy.
Uh-huh. Wow. Okay.
There are ways to tweak the trajectory and cut off a few months.
Okay.
But that takes more fuel.
Yeah.
And fuel is always a trade-off in space.
Right. I guess you'd have to pack a lot of podcasts for that trip.
Well, huh? Yeah.
But Are there any faster options being developed right now?
There are actually some very cool technologies that
Yeah.
could like drastically cut travel time.
Okay.
One is called the Variable Specific Impulse Magnetoplasma Rocket, or VESIMR for short.
Okay. I'm going to go with Vasimir.
Yeah, it uses electromagnetic fields to heat and accelerate plasma
Okay.
and creates thrust.
So it's like a plasma engine?
Exactly. It's still experimental,
Right.
but it could get us to Mars in 40 days.
That's incredible. 40 days to Mars.
And if we really want to push the boundaries, there's the idea of nuclear rockets.
Oh, wow.
Those could maybe get the travel time down to 2 weeks.
2 weeks to Mars.
Yeah,
That's practically a weekend trip.
right.
But what about even more futuristic stuff?
Like what?
Like those laser-propelled sails I've heard about?
Those are very what if.
Yeah.
But some scientists believe that they could send probes to Mars in like 72 hours.
So fast.
Yeah, just 3 days for information to travel between planets.
Okay, my mind is officially blown.
Yeah.
Let's bring it back down to Earth, or I guess Mars. We get there,
Yeah.
we set up our habitat,
Mhm.
we've even found water.
Okay.
How do we even stay in touch with Earth?
You've hit a very important point there.
Yeah.
Communication.
Right.
The distance between Earth and Mars
Yeah.
causes a big signal delay.
Okay.
It could be anything from a few minutes to like over 20 minutes,
Wow.
depending on where the planets are.
Oh, right.
This makes real-time conversations impossible.
Right.
And it could even be dangerous if you need to act fast.
Yeah, I can imagine.
Like trying to troubleshoot something with a 20-minute delay
Yeah.
would be very frustrating.
So what are the solutions?
Well, scientists are working on a few.
Okay.
One idea is a Mars orbital command module.
Okay.
It would act like a communication relay,
Oh,
allowing for more real-time control of robots and aircraft on the surface.
so like a communication satellite for Mars.
Exactly.
That's cool.
And there's another idea with a relay spacecraft in a very specific orbit. It's called a highly non-Keplerian orbit.
Okay. I'm not going to try to say that.
Haha, it's a mouthful.
Yeah.
But it would basically be constantly adjusting its position
Right.
using low-thrust propulsion,
Oh,
maybe from an ion engine or a solar sail.
wow.
This lets it hover over Mars and stay in contact with Earth,
Oh, that's very cool.
even when the sun is between the planets.
That's amazing.
Yeah.
Okay, so it seems like there are some options for staying connected.
Yeah.
But even with all this fancy technology, wouldn't we still need to be pretty self-sufficient on Mars?
Oh, 100%.
Yeah.
Like in situ resource utilization is critical.
Right.
It means using the resources available on Mars as much as possible.
Yeah.
And some people think we could even go beyond the planet,
What do you mean?
like space mining.
Martian space mining.
Exactly. Some scientists believe we could mine the asteroid belt for Mars,
Wow.
maybe using the moons as a base.
Okay.
That could give us a lot of material.
That'd be incredible.
Yeah, imagine a whole Martian industry. Space mining,
Yeah.
manufacturing,
Okay.
maybe even construction and tourism in the future.
I'm starting to see a Martian society forming.
Yeah.
But where would we even set up our first base?
Well, strategically speaking,
Yeah.
setting up near one of the poles
Yeah.
would give us access to water ice.
Oh.
And we could use natural Martian caves
Okay.
to protect us from radiation,
Oh, that's a Mars.
temperature swings,
Uh-huh.
and even meteoroids.
Wow. Yeah, that makes a lot of sense.
The Mars Odyssey actually found some good cave candidates.
Oh, really?
Yeah, near the Argemons volcano.
So we've got water, shelter, we're mining asteroids.
Uh-huh.
Can we just call Mars home now?
Well, that's where things get really ambitious.
How so?
Have you ever heard of terraforming?
I've heard the term,
Yeah.
but I don't really know what it means.
Basically, it's planetary engineering on a massive scale, like
Like-
transforming Mars to make it more like Earth.
Seriously.
Yeah, creating a magnetosphere, thickening the atmosphere, raising the temperature.
Whoa, that's pretty intense.
Yeah.
Where do we even begin?
Well, one idea is introducing ammonia into the atmosphere.
Ammonia.
Yeah, it breaks down quickly,
Okay.
but the nitrogen and hydrogen it releases could help make a thicker atmosphere.
Oh, I see.
And there's tons of ammonia in the solar system in icy bodies.
Right.
We could just redirect some towards Mars.
Instant atmosphere.
Exactly.
I admire the enthusiasm, but maybe we could look at some less explosive options.
Yeah, of course.
Yeah.
Another method involves using fluorine-containing minerals, which
Okay.
are common on Mars,
Right.
to make greenhouse gases like CFCs and PFCs.
Didn't we ban CFCs on Earth?
Yeah, because they were damaging the ozone layer.
Right.
But Mars doesn't have an ozone layer,
We are.
so they could help warm the planet.
Okay.
Now, a more controversial idea,
Okay.
and one that's been criticized a lot,
Okay.
involves, you probably know who.
Let me guess, Elon Musk.
Yeah. Of course. He suggested detonating nuclear weapons on the Martian polar ice caps.
For someone who wants to colonize Mars, he seems pretty okay with blowing it up.
It's a bold approach.
Yeah.
He argues it would vaporize the ice,
Okay.
release a ton of CO2 and water vapor,
Okay.
which would thicken the atmosphere and warm the planet.
Okay.
But a lot of scientists are worried about dust clouds blocking sunlight.
Yeah, that makes
And
sense.
there may not even be enough CO2 in the ice to do anything.
Right, and nuking another planet brings up a lot of ethical questions.
For sure.
Like, what about all those international treaties,
Yeah.
like the Outer Space Treaty?
Mm-hmm.
That bans weaponizing space.
Yeah, you're totally right.
Yeah,
Terraforming brings up a ton of ethical issues.
for sure.
Not just international agreements,
Right.
but also the environmental impact,
Yeah.
unintended consequences, even the basic question of if we have the right to change another planet.
That's a really good point.
Like, it's similar to the climate change debate on Earth.
Yeah.
We're only starting to understand what we've done to our own planet, and now we're talking about changing another one.
Right, so how do we even have that conversation about ethics?
It's complicated, but I think it starts with acknowledging we need a global discussion.
Okay.
Scientists, ethicists, policymakers,
Yeah.
even philosophers and artists
Yeah.
all need to work together to deal with these questions about Mars.
That's a lot of people. It sounds like these conversations need to be happening right now, before we even step foot on Mars.
The decisions we make now
Yeah.
will affect Mars and Earth way into the future.
Right. Well, it seems like our 15 minutes are almost up.
Yeah,
But this feels like it's just getting started.
I agree. There's so much more to talk about.
Well, to everyone listening, thank you for joining us on this deep dive
Yeah.
into Mars
Mm-hmm.
and colonizing it.
Thank you.
We hope this has made you curious
Yeah,
and maybe even think differently about humanity's place in space.
absolutely. It really makes you wonder, what impact would colonizing another planet have on us?
Yeah.
On, humanity as a whole?
Yeah, it's almost like a philosophical question, isn't it?
Totally.
Like, what would it even mean to be interplanetary?
Yeah, and it goes way beyond the physical challenges. There's,
Yeah.
Psychological and social stuff, too.
Oh, yeah, for sure.
Imagine the mental strength
Yeah.
to leave Earth,
Yeah.
knowing you might not come back,
Oh, wow, yeah.
and to live in, a tiny artificial world,
Yeah.
millions of miles away from everything,
It would take a very specific type of person.
Yeah, someone who loves extreme conditions.
Yeah.
Who's adaptable, resourceful, maybe even a little reckless,
Right.
but also someone who can work on a team, communicate well, and be emotionally strong.
Right.
All the research from those Mars simulations shows how important that is.
Yeah, those simulations are so interesting.
They are.
They really give us a glimpse into what it might be like.
Yeah, that isolation, that pressure.
They highlight how important psychological screening is.
Yeah,
Training before we send anyone to Mars.
for sure.
Speaking of, have you ever talked to anyone who's actually signed up for one of those missions?
I have, and
Okay.
it's always fascinating.
What are they like?
Well, their reasons are different,
Okay.
but there's always a sense of adventure,
Right,
a
yeah.
need to push the boundaries,
Okay.
and a belief that having humans on Mars is important for our survival.
It's like those early explorers who sailed across the oceans.
Totally.
Inspiring, but also kind of scary.
It is, and it reminds us of those historical parallels.
Yeah.
Like the age of exploration, we're
Mhm.
going into the unknown, driven by curiosity,
Yeah.
ambition,
All right.
maybe even destiny.
But history also shows us that exploration can be bad.
Yeah.
Like exploitation, conflict, unintended consequences.
Right. We have to be aware of that as we go further into space.
Totally. We need to learn from the past.
Yeah.
Make sure we approach Mars ethically
Uh-huh.
and responsibly.
We can't repeat the mistakes we made on Earth.
It's about finding a balance
Exactly.
between exploring and expanding
Yeah.
and protecting and preserving.
Finding that sweet spot between pushing our limits and
Yeah.
making sure we benefit everyone.
On Earth and on Mars.
Exactly.
Okay, before we wrap up this part,
Yeah.
I got to ask about terraforming again.
Okay.
All this talk about ammonia asteroids and nukes.
Yeah.
Are there any ideas that don't sound like they're from a sci-fi movie?
There is one that's pretty ambitious, but also really elegant.
Okay, what is it?
Creating an artificial magnetosphere for Mars.
Wait, a magnetosphere?
Yeah,
Like Earth's force field that protects us from solar wind? How could
exactly.
we even do that?
It sounds
Yes.
crazy,
Yeah.
but researchers in Japan are actually looking into it.
Seriously?
Yeah, at the National Institute for Fusion Science. They want to build a system of superconducting rings around Mars.
Superconducting ring, like giant space magnets.
Pretty much they would go around the planet's equator
Okay.
and be cooled down to superconductivity that would let them carry a huge amount of electricity.
And then what?
That current would create a magnetic field strong enough to deflect the solar wind.
Oh, wow.
Basically an artificial magnetosphere.
That's incredible, but that would take a ton of energy.
It would be a huge project for sure,
Yeah.
but the researchers think this magnetosphere could also transfer and store energy,
Oh, wow.
like a giant Martian power grid,
Okay.
using solar energy and spreading it across the planet.
So we're protecting Mars and powering a civilization at the same time.
Exactly. It's a big idea.
Yeah.
And we still need to figure out a lot of the technology,
Right.
but it shows the kind of thinking we need if we're serious about Mars.
It's amazing to think that what used to be science fiction
I know.
is now possible.
Yeah. It shows how ingenious humans are and how much we want to push the limits.
But even with all this amazing technology and all
Yeah.
these smart people working on this,
Mm-hmm.
I keep coming back to the same question.
What's that?
Why Mars?
Yeah.
Why go through all this trouble to colonize a planet that seems so dangerous?
That's the big question, isn't it?
It is.
What makes us reach for the stars, even when it's so risky?
I don't think there's an easy answer.
No, probably a lot of reasons.
Right.
For some, it's about survival,
Okay.
like a backup plan if something happens to Earth.
Yeah.
Others want to explore the unknown,
Right.
solve the mysteries of the universe,
Yeah.
maybe even find out if we're alone.
And some people just love the adventure,
Yeah.
the challenge, to be pioneers.
Exactly, to push the limits of what humans can do.
It seems like there are as many reasons to go to Mars as there are people.
It's what makes it so interesting to talk about.
So we've talked about like why we would even go to Mars, but what about the how?
Right.
I mean,
Yeah.
what would it be like to live on another planet? What challenges might we face that we haven't even thought of yet?
That's where things get really interesting.
Okay, tell me more.
We're talking about creating a brand new society, from scratch,
Yeah.
on a planet that's completely different from Earth. Everything we just expect here, the air, the food, day and night,
Right.
all of that would have to be made artificially or adapted to Mars.
It's mind-blowing when you think about all the details,
Yeah.
right? Big and small.
Yeah, exactly.
Everything from like trash to how people are feeling mentally to
Wow.
even just like telling time on a planet with a different day and night cycle.
Right, exactly. And don't forget about evolution.
Well, okay, yeah.
Over generations, would people adapt to the lower gravity, the different environment?
Right.
Do they become like a whole separate species from Earthlings?
It's like something out of a science fiction novel.
It really is, but it's a future that could happen while we're still alive.
Yeah, that's why this conversation is so important. We need to talk about all this now before we go too far with Mars colonization.
Right.
So we're prepared for everything that comes next, good and bad.
I agree.
Well, speaking of challenges, one thing I keep seeing in our research is radiation.
Yeah.
We know Mars doesn't have that magnetic field like Earth does.
Right.
So colonists would be exposed to way more radiation. What kind of health risks are we talking about?
It's definitely a big concern.
Yeah.
More radiation can mean higher risk of cancer, DNA damage, all sorts of problems.
Right.
So any habitat on Mars would need serious shielding, maybe even using the Martian soil or water ice,
Okay.
like as natural barriers. And the people living there would have to really track their radiation exposure and take steps to minimize those risks.
So it sounds like living on Mars, you constantly have to be thinking about your environment and being careful.
Yeah, it would be a big lifestyle change.
For sure.
But humans are adaptable, right?
Right.
We've managed to survive in some crazy places here on Earth.
Yeah, that's true.
The Arctic, the bottom of the ocean, we find a way.
We're a pretty tough species.
Exactly. We're resourceful, we're resilient, and I think we'd find ways to deal with living on Mars.
Yeah, you're right. We have a knack for problem solving.
We do.
But what about the mental side of things? Being so far from Earth, not much communication,
Yeah.
stuck in a small space with just a few other people? That sounds isolating.
Well, it would be a challenge for sure. That's why it's so important to choose the right people to go to Mars. They'd need to be screened, make sure they can handle stress, isolation, being in close quarters.
Yeah.
And They'd need training in conflict resolution, teamwork, communication.
So it's as much about the people as it is the technology.
Absolutely. It's a human endeavor at its core.
Right.
A Martian colony would succeed or fail based on the people we send and how they work together to build that community.
So given all that, why do you think people are still so drawn to the idea of Mars?
Hmm.
I mean, what's the big goal here?
That's a question with a lot of answers.
Okay.
Some people, it's about pushing exploration further than ever before, having humans permanently in space.
Right.
Others, it's about the science.
Yeah.
Discovering the secrets of Mars, maybe even finding life, past or present.
Okay.
And for others, it's about survival, making sure humans have a future, even if something terrible happens to Earth.
It's a really interesting mix of motivations.
It is.
Curiosity, pioneering spirit, even a bit of like existential worry.
It's exactly that mix that makes this whole conversation so fascinating.
Totally agree.
We're not just talking about a mission or some new tech.
Right.
We're talking about how we understand ourselves,
Yeah.
humans, and where we fit in the universe.
It feels like the story of Mars is still being written.
Yeah.
Like we're at the very beginning of something
Yeah.
that could change everything for humanity.
And it's up to us to have this conversation, ask those tough questions, think about what's right and wrong, and help shape how we explore space.
So it benefits everyone.
Exactly.
Well, this has given us so much to think about.
It's been great talking about this with you.
Thanks for listening, everyone. We hope you enjoyed this deep dive into the world of Mars. Maybe it sparked your curiosity. Maybe it made you want to learn more about this incredible journey we could be on. And if you like the show, be sure to like, subscribe, and tell your friends about 15-minute discourse. Until next time, keep exploring.